Hey guys, we'll be starting shortly, so just stay tuned. All right. Hello everyone. This is Ayush from second year CSC, and joining me is Aditi. So we both are from Technical Council, and today we have an interesting session for you on data science. We just had this idea. Like just think about it. Humans evolved. All other organisms also evolved. So how does evolution occur? Basically, evolution happened when we had some experience. The organism had some experience. It learned something. It modified itself, and then based on the experience, the next generation was formed. So if you think about it in a way, all the organisms on this planet are just data machines. We process data. What is the data? The world around us, the environment, the food we eat. All this data goes into us, we churn it out and comes out the next generation. So in this session, we are trying to get you guys into the world of data science.
Data science is poised to be the future of tech industry. In recognition to this, Technical Council brings DataCrunch, a data science hackathon as a part of our Grow From Home series. All enthusiasts, irrespective of their proficiency in that data science, can compete to take away prizes worth 15K. DataCrunch is completely beginner friendly with curated preparatory materials to help learners get up to speed on data science. At the end of the session, we have some important details regarding DataCrunch. So let's get started.
Okay, so who better to bring you details about the field than our alumni? So to bring start of the session, we have Dr. Ahmed Khalid Ahmed with us. He is an alumni of our college. He studied here in the chemical department. He's from the 2010 batch. And after that, he completed his education in the University of Michigan. He holds a master's degree as well as a PhD degree in chemical engineering. After that, he has a work experience of 5 years in the field of data analytics. So allow us to welcome Mr. Dr. Khalid Ahmed into the show.
Hello, can everybody hear me clearly?
Hello,
It's an
sir.
honor to
Welcome.
welcome you once again into this an initiative of NIT-T. Welcome, sir.
Welcome. Thank you, Irish. Thank you, Aditi.
So, how
So,
does it
sir,
feel like to get connected with NIT-T Juniors?
Yeah, it was exciting. It was when I saw Ayush's message over LinkedIn, I was like, oh, this is great. I'm really glad to see that you guys have such an initiative. It's very nice that you guys are trying to that you guys recognize that data science is the future of the tech industry, like you mentioned. And I think NIT Trichy has always done this, right? We as students we recognize, and then it's the students who carry forward the initiative to bring the future to everybody else. That's the best part of NIT Trichy. I think that we help each other out so much.
True,
definitely,
sir.
sir.
Very true. So, any piece of advice or stories, anecdotes you have to tell to NIT students from your time?
Stories, anecdotes. So I was talking to Ayush yesterday, and he was telling me how you guys had, due to the whole COVID scenario, you had to all basically college had to stop at the end of your first year and so on. I was thinking back, and I was realizing, so in my first year I was in Agate, right, the hostel Agate, and I remember that it was when I was going back home at the end of my first year. That was, the most nostalgic moment for me, because it was like we had all, developed this relationship. We found such good friends and stuff, and then there was going to be this whole summer gap. And typically, first years in summer, we don't have internships, we don't have
True.
anything much, right? So once you go to the second year and third year, you're looking at research options, internships. You're trying to go to IIT Madras professors, or everywhere you're trying to get something done. But at the end of your first year, you don't really have much planned down, right? And so you're suddenly like, oh my god, all the time I spent playing with my friends, what am I going to do? And mentioning playing with my friends, so we used to be, so we were in the third, was it third floor? Yeah, I think the third floor of a gate. And we used to actually, so the warden did not know this, and we've obviously everybody has their own stories of breaking the rules. We used to play cricket in the corridor, right, in the hallway, with a proper ball and everything. We've broken so many lights over there, and so many tube lights, and we'd be one of those people who'd go to the store and keep buying tube lights just so that we can fix them back without anybody knowing that we broke the tube light. So that's one of the advantages of Agate, right? Because we have that weird, the weird like prison-like feel. So
Yeah.
nobody can see that we are playing. The ball is not going to fall outside. I mean, it could, but because of small holes. But yeah, we used to play. We used to play in the hallway, and it was like basically cricket net practice, right? So yeah, it was perfect. I'm sure many
Amazing.
of you guys still do that. I hope you guys still do that. I think that's
Yeah.
part of the NIT Trichy experience. I see Ayush nodding his head. That's awesome.
Yeah. Okay.
That's from dorm life, and then of course, so when I was in chemical engineering, uh, by the time I was in my third year and final year, we were in Garnet. And so it used to just be that, walk down that one road to get the chemical engineering department. And so it was really our department and our hostel were pretty close to each other. But still, we used to try to find excuses to not go to classes. Our class rep was great in making sure that classes got rescheduled and stuff. So one thing in hindsight, like I like to say, right? So undergrad is a very broad program, right? Um, so it is really good that on one hand you have a technical council that's trying to expose students to the latest fields, data science, and so on. And I'm sure you're exposing them to many other fields and across different departments, right? At the same time, the undergrad curriculum is very fundamental in its nature, right? You learn the fundamentals of engineering. And what I want to say is that is very important because as you go, ahead in future, what you will learn is that the most important thing for you to take from school is learning how to learn, right? Finding out what works for you, right? And different people, different things work, right? Like I knew somebody who he would cheat in exams, but that was his way of learning. The process of cheating taught him stuff because he would never sit in the dorm and study, right? But when he's preparing his, cheats and all that stuff, that's when he's learning, right? So the point is, when you're going through undergrad, you need the most important thing is you need to learn how to learn so that as you move on in life, you can learn things very quickly. And as you all know, today, technology changes, fields change. So if you know how to learn things, then you're very good at moving on to fields, moving on to technologies and stuff like that. My wife is a science teacher, and before, like when we were young, we used to be told by our teachers, what do you want to be when you grow up, right? And people say, I want to be a data scientist or whatever, right? I want to be engineer, I want to be a doctor and stuff like that. Today, they don't tell the students what is one thing you want to be. They say 5 things that you want to be when you grow up, because technology is changing so fast, right? Today you may be a computer science engineer, tomorrow you have to become something else. So anyway, that's a little bit about NIT Trichy days.
Right,
Yeah.
so very true.
So
Yeah,
that brings us to our next question. And so, okay, so we have seen your profile. Okay, so it really surprises me that you have studied everything about chemical. You've gone in depth into chemical. You have a master's degree, you have a PhD degree in chemical. So when did you finally decide, okay, I'm going to go ahead with data science? Like where did this interest come, and how did you make the transition from like chemical guy to transition to the software side?
Right, right. So that's a very good question. It's a question that I'm asked very often as well, right? So kind of going back to what is chemical engineering, right? Chemical engineering is a very broad field, right? So for many of us who are currently in chemical engineering, they might end up going through biotechnology, medical research, like vaccine development and stuff like that. For me, my turning point was when I was in NIT Trichy in my second year. I got that JNCASR fellowship, and I went to the engineering mechanics unit in JNCASR, and I started doing computational physics. Right, I started doing molecular dynamics simulations. So I started getting into dry lab research. Right, in fact, it started with at NIT Trichy. I was like working with like some master's students, like they were doing their masters at that point in time over like CFD and stuff like that. And then from CFD, which is a continuum based simulations world, I went into molecular dynamics in molecular dynamics simulation. So in other words, I went down the high performance computing route, right? And then when you go down the high performance computing route, you basically start developing those software skills, right? Now, by no means am I a software engineer, right? On any day, I think even any of you guys, especially people who work in Spider and stuff like that, if you and I sit down for a hackathon, you may be able to solve the problem faster than me, right? But the catch is, and as we go forward, right, the world is valuing the combination of skills, right? So on one hand, you may be a good software engineer, but on the other hand, you also have to be good at, say, math, right? And so chemical engineering does a lot more of math, right? So we do like Laplace transforms and stuff like that, because chemical engineering, in definition, is scaling up, right? So the chemist finds, the chemical compound in the lab. The chemical engineer says, okay, if this is how you made it in the lab, this is how I will make it in the industry. And that requires a lot of math and physics, right? So now what's happening is, for me, for example, so then I went from chemical engineering to simulations, right? And simulations were very much chemical engineering. Then I came to Michigan for my PhD along the same lines of simulations. In Michigan, doing simulations, what I started getting into was, how do you store all this data that the simulations are creating? And then from there, I went into like, looking up like MongoDB and stuff like that, right? Like NoSQL databases and how best can we take advantage of, all the work that I'm doing to make my own work easy. And actually that was the, like, they always say, what was the tipping point, right? The tipping point was, so one of the things we used to do, the tipping point in short was trying to make my own life easy. I got attracted towards data science. So what do I mean by that? This is before the time of Google Scholar, if anybody knows what Google Scholar is. But basically, what we used to do, what I did was in my lab, I used to, on a weekly basis, go to all the research journals and look through all the papers that are being published, right? I just read the title. I read the title and say, do I want to read this or do I not want to read this? Do I want to read this? Do I not want to read this? And that is a very simple data science problem, right? It's a basic Bayesian probability problem where you can just take the words in the title and say, are these words, matching the library of papers that you have already read in the past, right? So we started there, and then so that became a project that I did in my grad school, and then from there I was like, wait, this data science thing is so cool. How can I start helping myself? And then went into data science, and then today, right now, again, back to my original point about merging two fields, right? So today I work in electrified powertrain engineering at Ford. Electrified powertrain basically means like hybrids and electric cars and stuff like that, right? And what is the most biggest component in all these cars? There is a battery. There is a high voltage battery. There's a big battery either in the trunk or under the seat or something like that. But battery is again chemical engineering. So you see how I kind of brought those two fields together, and so I'm doing data science, but I'm taking advantage of all the chemistry I learned, all the lithium ion chemistry, the inorganic chemistry I learned in my undergraduate.
That's wonderful,
That
sir.
was a
So,
yes, sir.
huh, go ahead.
Yeah, so that transition that you have explained is like very less expected, but very smooth.
Yeah.
So that was really amazing to know.
Yep. Thank
Yeah,
you.
so actually the thing, sir, with data science is that people just imagine it to be this wonderful field, magical field. Like you have the circle, you just send in all the data, the computer does some magic, and out comes the answer. So
Yep.
we would like to know from you, a person who has worked with real life data, like could you describe how data science would be? Let us say I'm a person who has no idea about data science at all. I'm someone from the past or something, and I don't know
Sure.
anything about data science. So how would
Sure.
you describe the basic idea of data science, like how it happens?
Yes. So yeah. So I always like to let me see if I can share my screen over here because I really like this couple slides uh, that I have. Three rare that happens. Okay, let's try this. Let's try my entire screen. Share. Let's see if it works. I think I'm sharing my screen. Is that right? Yes, I am. Perfect.
Yep.
So this is a class that I taught somewhere inside of Ford, and I basically want to show a couple slides over here, right? Um, so and I'm assuming that you're brand new to data science when I'm showing you this, but even if you're not, and if you're not, you've kind of already seen this, right? So the point over here I want to show is this, hello world of data science, right? There's something called the Iris data set. Almost everybody over here who's done any reading on data science must have heard about it. And the basic idea of the Iris data set is that there are data points about the species that different flowers belong to, right? So there's a sepal in a flower, there's a petal in a flower, there's a sepal width and a sepal length, and then basically somebody in 1936 went and measured all of these and said what species does a particular flower belong to. Now, what data science really does is takes this data and plots it on a plot, right? So let's say we plot sepal length versus sepal width, and we start coloring up the data points according to the species. So the species is what we want to guess. So in other words, we just want to measure the sepal width and the sepal length, and we want to be able to guess what species the flower belongs to. So essentially, what data science is about teaching the computer to pick the right features, which means picking the right thing, that is sepal width and sepal length, Because remember, we had 4, right? We had sepal width, sepal length, petal width, petal length. But it's about picking sepal width and sepal length, and essentially coming up with this separating boundary. Okay, that's what it's called. Coming up with this separating boundary. And if you notice, in this case, this separating boundary only helps you distinguish between setosa and others, right? It doesn't tell you between versicolor and virginica. But at the very least, this separating boundary can tell us what is setosa, such that if I now bring a new data point, right? If there is a new flower, and if I say its sepal length is 6.2 and its sepal width is say 4.4, my machine learning model, because it has learned this separating boundary, can guess that this data point belongs to setosa. So data science is not black magic. In fact, it does not work like this, right? It does not. It is not that you have a robot and you show it a book and it reads the book. That's not how data science works. The way data science works simply is when you have a when you have a data set, the machine learns this boundary. And if you notice here, I drew a linear boundary, right? And some of you might be thinking, okay, that is cool, but how do you distinguish between versicolor and virginica? Well, that implies for separating between versicolor and virginica, you cannot do it using the sepal width and sepal length. You have to look at the data from a different perspective. Maybe you have to look at the petal width. Maybe you have to look at the petal length. By the way, that's called feature engineering. But the point being that data science is that simple. It's as simple as the finding the patterns in the data such that when a new unknown data point shows up, you can guess which family that data point belongs to. I usually like to use that as my introduction to what is data science. I hope that was helpful.
Yes, sir.
It was very simple and subtle and yet very impactful.
Yep.
So we have this. We have a lot of beginners here. Okay, so we have a lot of questions. They have a lot of doubts about how they should go. Like there's one such comment here, and he's asking about how a guy should get into data science. They have a lot of sites like Kaggle, which holds a lot of data set. So once if you just go and view the data, it's quite scary. So how should a guy make a transition into data science? How should he learn it?
Okay, so this statement of mine is not just for data science, Ashwath. If for anything you want to learn, okay. And remember, what did I tell you? Undergrad is about learning how to learn, right? And for every person, that's different. So you need to find out what is the best way for you to learn. Now, having said that, Ashwath, the concept of divide and conquer, right? And I think we do this in programming, right? We build small functions. This function does one job. This function does another job, right? That is the basic idea of how do you win in any field, right? Now for data science, Kaggle is great because it has so many data sets. It's also great because if you go to like historic problems, so don't go to a current Kaggle. So if you're getting started, my suggestion is don't go to an existing competition unless it's being set up by DataCrunch. Then that's great because you have all the support system. But if you're working in a vacuum, right? Let's say you don't know anybody and you're working in a vacuum, then my suggestion is go to historic problems because then you have the solution. And most people usually put up a solution on GitHub. Now, don't cheat. Don't start with the solution, right? Start with thinking about how would you approach it, right? Start there. The other thing I would so two pieces of advice. One is divide and conquer. Other is start with historic problems where there's a solution, and recognize that what you come up with as a answer is going to be very different from what is the winning entry and stuff like that, right? But that's the learning process. You will get there. It takes time, but that person also started somewhere. Does that help, Ashwath?
Do let us know in the comment section, Ashwath, if that was helpful for you. Now, Ayush, we can move forward.
Okay, sir. So we have one more guy here, and he's asking us a question about how do you need to become a full stack developer before venturing into data science?
Oh no,
So
yeah. Good question, Pranav.
Yeah, it's a pretty trivial question, but a lot of people come up with this. I've seen a lot of people ask questions about this, like, should I go into the software? Should I start from web dev, app dev, and then go into other stuff? Like, how does it work?
Yeah, no, good question, Pranav, and nice that you brought it up, Ayush. So, short answer, no. Okay. Long answer, so it depends on the industry and the company you work at, right? So, for example, during my from my PhD lab, so you remember I told you we were a group of people who did that Google Scholar type project. One of my friends, he went to work in a startup called Olark. Olark is a startup that so basically builds chatbots for different websites, right? Um, so the point I want to make here is because he was working in a startup, he was working in a very small company. So you in any startup, and this is the good thing about startup experience, right? You take up a lot of roles, right? So one of the roles you take up is you might end up having to do the front end, the back end. Hence, you might end up needing that full stack development, profile and experience, and then you might need to do data science on top of that, right? So in startups, yeah, but as the field of data science matures, and I think by the time you guys graduate, right, the field of data science would have matured a lot more, such that now people distinguish between, okay, this guy is a software engineer, he is doing full stack development or front end development, back end development, and this other guy is a data scientist, he is building machine learning models, he's probing the quality of machine learning models, improving accuracy and stuff like that. So as the field develops, that distinction is getting more clearer. And what do I mean by that? So if you go to a big company like mine, right? So I work for Ford Motor Company. There, we are like a 200,000 people company. So we have a complete IT department, and then we have a complete data science department, right? So there's a clear demarcation. So any IT work I need to do. So for example, let's say I build a model. For making the model go live on a website, I usually don't even handle that. I just go pass it along to the IT team and say, this is my model. You give it this API call and it'll give you this result, right? And then somebody else hosts it. Somebody else takes care of that complete business. And that's basically because of that distinction between, companies that have a mature data science department versus companies that don't. And if we have time, right? Like one other thing, I like to always think of the analogy of like webmaster in the 1990s. So if you go back and read historic articles, right? And by the way, this is the best thing you can do to improve your knowledge, like read, right? So when you read about like, how did webmasters develop in the 1990s, when internet was a new thing, they used to have one position called webmaster. The webmaster did front end, did UX, did UI, did UX UI, did back end, did everything, right? But today, Facebook doesn't have one job called webmaster, right? They have clear role distinctions. And that's what will happen. When data scientists were first, like in 2010 and all, if you are a data scientist, you got to do everything. You got to do full stack development plus machine learning, everything, data cleaning, machine learning, everything. Today, it's getting more clearer.
All right, sir. So we have one more question here. Okay, so there's this question. He has a question saying that he's a novice in data science, and there are so many concepts when you come to data science, especially like machine learning. You have deep learning, you have AI, all that. So he's pretty intimidated about which to choose. He has no idea. So he's asking about your experience about like how should he go about this.
Yeah, it's a very, very good question again. So my main suggestion is, so first there are the tools and then there is the algorithms, right? When you're getting started, pick a tool that you're already comfortable in, right? So for example, if you're somebody who does Python, just do scikit-learn to get started with, right? If you're somebody who does MATLAB, go ahead and start with MATLAB's machine learning toolbox. I personally don't like that, but what I'm trying to say is, don't you want to learn machine learning or data science, you don't want to be learning MATLAB, right? You don't want to be learning Python, right? So in the first round, your goal is to learn about algorithms, right? Now, if you don't have any tool, then you can smartly pick a tool that is widely used, Python. But if not, basically pick the algorithms that you're learning. Now, and then start with something as simple as scikit-learn, right? Just standard, single core, single processor machine learning library. And then most of your data sets scikit-learn can handle. And then when your data sets get larger, if you have learned the algorithms with scikit-learn. Then as you move, let's say to Spark ML, basically all Spark ML does is takes those same algorithms and then vectorizes basically such that you can apply the same algorithm but in a distributed, parallel computing manner, right? So you can learn that, or you can like act like a black box, right? You can be like, I know what k-means algorithm does. I don't really need to know the exact details of how Spark ML vectorizes the k-means algorithm. So I will just, because I learned k-means in scikit-learn, I'm fine with just picking up, with just using Spark ML. Now, deep learning, little interesting caveat over there with deep learning is, in my opinion, again, this field is a little bit opinionated as well, so keep that in mind. What I say, somebody else might disagree, and I'm fine with that. Everybody can have their opinion, right? So deep learning is a little bit of value only when you have a really large number of features or you don't know how to pick your features, right? So for example, for me in the automobile sector, everybody needs physics-based features, right? So they'll say, if I say the fuel economy is dependent on the third principal component, they'll be like, what the hell is the third principal component, right? What are you talking about? And then I have to tell them, well, it's actually the velocity cubed times the acceleration. Like they need a physics-based definition because at the end of the day, we're building a car, right? So things like that. So deep learning is very useful in industries where there is no really need for a physics-based explanation. So for example, image processing. Why is this the image of a cat? Yeah, whatever. It's the image of a cat, right? Now, we are also kind of going down there for all of our autonomous vehicle stuff. So where we have recurrent neural networks and stuff like that. So deep learning comes in to play in two parts. One is where the features are a lot, or two, where you don't really care for the physics. But my point is that should be your last frontier, right? Start with a tool, right? Get very good in Python. Then start with Python's own inbuilt like scikit-learn. Then go to Spark. Then from Spark, go to Spark ML. Then from Spark ML, start looking into TensorFlow and then go into deep learning.
That's wonderful, sir. So we also have one more question from one of our friends called Madhav, and his doubt is he's studying design basically. So he's been told that you need to learn ML and you need to learn front-end development and all that. So he's asking, as a data scientist, how often do you work alongside designers and like how do you work through this?
As a data scientist, I basically don't care too much about my designers. I tell them this is my function, this is my model, this is my API call, right? But if I see a design that's really bad, that's when I would step in and say, come on, man, like because the value of my work goes down, right? The value of my work is in their hands. But at the same time, to Madhav, my advice to you is, the most important thing is to be able to communicate, right? So if you know the parlance, like the way data scientists speak, that will help you as a designer. If you want to become a data scientist, then like for me, if I know how designers speak, by the way, I don't, right? I'm not a software engineer guy. I don't know how UX UI designers speak, but if I did, that'll help me in my work with them.
Okay. Sir, we have all these questions, and I see this question quite frequently. There are a lot of people who have taken up chemical science or mechanical department here, and they really wonder if it is possible to go into data science. So you have told this time and again, so I'd like to just give a short message to them, like how
Yeah.
it's possible.
Absolutely. So, in fact, specifically to those of you who are in the original 5 engineering fields, right? Keep in mind that what you're learning at an undergraduate level is the fundamentals, right? The entire world is open for you. You can specialize in whatever you want. Data science, absolutely. And keep in mind that data science is the in thing today, right? Maybe 20 years from now, it might not be data science, right? It might be robotics, right? It might actually, robotics was the in thing. Like when I was an undergrad, robotics was the in thing. I still think it's the in thing, but just saying. So the most important part is that you need to recognize that you're learning the fundamentals in undergrad, and it's important, focus on those fundamentals, but the entire world is open for you. That's where you can do a master's, or even now the world is moving a lot towards online education systems, right? And for us personally, like when I hire people, personally at least, I recognize online education. if you can back it up with projects. So if you have a good GitHub profile with a good function and the good model, if you have it hosted somewhere on AWS like an S3 instance, we respect all of that. So online education is a great option, and undergrad is a great place for fundamentals. And the last point is your success is in your unique position to merge things together. So my success genuinely has been in bringing chemical engineering, battery chemistry knowledge to the field of data science.
All right, that was very insightful and clear, sir. Thanks for answering that. Also, as most of our attendees today are just starting with data science, so
Yeah.
talking about skills, what do you think are the required skills or prerequisite that uh, for someone who gonna start with data science, and what programming languages you think are required for as
Yeah.
tools or something like that?
Yeah, so I think I would merge this with the previous question of mine, and I think even Sham's question over here. Like, yeah, I think the prerequisite really kind of depends on what you're strong in. If you're strong in MATLAB, don't say, okay, I have to learn Python just to learn data science, right? Because for all you know, you may find Python so frustrating that you end up never learning data science. So I don't want to lose you there, right? So if you know Python, start with Python. If you know MATLAB, start with MATLAB. If you know R, start with R. Now, let me switch the other way around, right? As a manager, who do I hire? Do I hire the guy who knows MATLAB data science or Python data science or R data science or Alteryx data science? The answer is I actually hire everybody, because in the team that I want to build, I want somebody who's good in MATLAB's libraries, somebody who's good in Spark's libraries, somebody who's good in Python's libraries, and somebody who's good in R, because everything is good, right? It's hard to say this is the only thing that we will use and we should use. But having said all that, if you're truly a beginner, this is my opinion. I think Python pandas is the future, just because Spark also does data frames and that concept. And so I think it's pretty cool if you can, if you're just getting started, start with Python and pandas. There's a very nice book called Python for Data Science by Jake Vanderplas. That's kind of one of my recommendations if you're a book reading kind of person, right? If you're on online YouTube videos and Simply Learn and Analytics Vidya and Thinkful and stuff like that, then yeah, there are a lot of other options.
Thank you, sir, for that. By the way,
Right, sir.
participants, we have also provided you with resources. So you could go
Nice.
to Drag that has been selected selectively for beginners, so that will help you out. Okay.
Awesome.
And so we have this very big doubt as like a data scientist. If I'm going to pursue a career in data science, then what is going to career path going to look like? So there's a lot of comments in the section here about like what data science is going to be in the future, or how is the career going to go. So sir, could you share some insights about that?
Okay, so the future is all about. I mean, I don't know, right? I mean, I don't know the future. That's the correct answer. The correct answer is like I don't know what's going to happen because it's a brand new field. Now, having said that, I always draw an analogy from between data science and the webmasters of 1990s, right? When the internet came, in the first 10 years of the internet, there was like Amazon started in 1997, Facebook started in 2005. There was nothing big happening, right? And still there was the dot-com bubble, right? Internet companies were, and read up about these things, right? If you like to understand where the future is going, you have to look back at the past. So a lot of these, the dot-com bubble and all of stuff kind of tells us that there will be an initial hype phase, and then data science will become common across all industries, right? Now, in terms of career path, I think data science is absolutely on the technical career path, right? You're going to be a data science. So for me, for example, I started as a data scientist, then I became a senior data scientist, then I became a technical expert. Typically in Ford, you go down the technical path, then you become a technical leader. Basically, all this implies as you go higher and higher up is I'm getting lesser and lesser hands-on, and I'm getting more and more broader, right? So now I have a team of 6 people working for me, and they're all doing the actual modeling, but they're all using a lot of historic code that I developed. But that's basically how your career is going to progress. So rather than when you start, you have probably one project or one client, but then as time goes, you will get broader and try to use the same solutions that you developed, the models that you used across more projects by having more members and stuff like that.
Sir, also some of the students would want you to repeat the name of the book. We'll provide them with the link.
Sure. Yeah. So if you guys have resources, that's great. This is just like my personal favorite that I'm talking about. So it's called Python for Data Science, and the author is Jake Vander Plas. The best part is the entire book is available through GitHub. So you can just Google search Python for Data Science, and you will find the book.
Thank you, sir. As we have seen, you have already been involved in mentorship. What would you like to say about importance of sharing earned experience and giving back to the community?
That's a very good question, Aditi. Yeah, so it is rewarding. And I'll tell you why. Because one of the things that we all need to realize is, um, what am I? I'm like 10 years older alumnus than maybe you guys, right? I'm 2010 and you guys are 2022 and other near around that time frame. However, this does not mean anything when you enter the industry, right? It could be that 5 years from today, Aditi has her own startup, and then she is the CEO, she is the next big Fortune 500 company, and I want to come and work for Aditi, right? So once we recognize this, what we realize, what we want to do is we want to help each other reach their best potential, and doesn't mean it has to be data science, right? Aditi might end up starting a cooking startup. I don't know what your interests are. Okay, just making things up over here. But whatever startup you make up, right? And maybe that's the future. And maybe in that cooking startup, she wants to do some data science of which. And by the way, I've come across some really cool projects where they try to decide which ingredient makes the recipe most liked by people. Data science, right? You can see stars of ratings and stuff like that. So the point being, data science is everywhere, and we all really, when you give, that you always get back, right? So very important, so it's very important for you to help each other out. And the implication for the stage of your life where everybody else over here is if you all work together, you can work on more projects, right? So think of it as, let there be one project that you're the lead on, but then you want to be helping your other friends in, let's say you have 5 friends. If all 5 of you are leads on 5 projects and the other 4 are helping in that project, now all 5 of you can put that down on your resume. And yes, you will talk the most about that lead project, but you also have influenced other projects, right? And that's the most important thing that we look for. We look for people who have a breadth in their expertise as well as in their experience, right?
Okay.
Right.
Uh,
Thank you. That added another side of our answer. Like we were expecting, it was much more than that. Thanks for that answer.
You're welcome,
and
Aditi.
so we would love it if you could explain any one of your projects that you've been working on, something like real life, to just give an idea. We have a lot of intermediate and advanced people also here. So, like,
Awesome.
could you describe one of your projects for them, like something which you're working on?
Sure. So I was thinking about this. I was, what do I want to share? And I'm just gonna verbalize this. I don't want to share anything because of privacy concerns and stuff like that. But we have a project with what we call trip prediction. So again, I work in the automobile industry. I work specifically in powertrain. I work in electrified powertrain. Electrified powertrain basically means effective. There are different types of electrified powertrain, but essentially it means you have both an engine that can run the car, or you have a battery that can run the car. So now the battery is actually very efficient to run the car on the battery is very efficient at low speeds. So when you're inside the city at low speeds, it's very efficient to run the car on the battery. When you're on the highway, it's actually very efficient to run the car on the engine. So what we do in data science, how does data science come into all of this, right? So what we do is we predict, when you start a trip, we try to predict where you're going to go and how you're going to get there, right? So, and this is purely based on, okay, it is 8 o'clock in the morning on a Monday, so you must be going to work, right? So what am I saying? My features over there are time, day, and also a lot of learning, right? So a lot of k-means clustering of, based on this k nearest neighbors, really. Based on this starting point, what were the other trips that started around this starting point? Where did they go to, right? So based on that information, we can basically predict that you are most likely going to go to work. And then we also have to say, if you're going to go to work, this is the route that you're going to take, which means that you're going to get on the highway first, and then you're going to get on the inner city to get to your actual, maybe you live in the outskirts, right? So you're going to get on the highway, and then you're going to take an exit, and then you're going to go through some inner, like downtown roads to get to your office. So you actually want your battery to be available for you in the last part of the trip, whereas in the first part of the trip, you want your engine to be on. So basically what this is using data science to help with controls and more really controlled options. So basically what this trip prediction does is every time you start a trip, we basically run a k nearest neighbors. We say this is most likely the trip. Then we run a neural net that says, if this is most likely the trip, what is the acceleration? How are you going to drive at different points? So it's called a trip trace. We try to estimate your trip trace. And the best part is this whole thing is streaming, right? So if you're not going down the highway, if you keep going inside, we say, whoops, you're not going to the highway, you're going somewhere else. We got to correct our prediction based on streaming data, Spark streaming data, and then say controls have to change accordingly. And then we predict, okay, so we're going to turn the engine off, turn the battery controls on, things like that. Was that a good high level example?
Yes, sure, sir. Thank you so much for your participation, sir. We really appreciate you taking time out of your busy schedule and trying to attend one of our college sessions. We hope you had a good time, sir. Thank you so much for participating.
You're welcome, Ayush. Thank you, Aditi, and thanks everyone for the great questions. And I wish you all good luck with the data crunch, and I'm sure that you guys will find that very useful and productive. Let's stay in touch, okay?
Sure, sir. Thank you for joining
Thank
us.
you, sir. Thank you, sir.
Thank you, guys. Bye.
All right. So, thanks to all our audience for joining us today. But before you leave, we have small announcement to make. Hackathon gonna start tonight, and registration forms are still open till 8. Only after you will register, you'll be added to WhatsApp groups, and there all the informations will be shared. Further information will be conveyed through the WhatsApp group itself, and the book that sir has mentioned is added in description of this video. So check that out there. Another thing, don't forget to check our tomorrow's webinar that is scheduled at 4 tomorrow, and it's again gonna be a really insightful session where various experience-based, learning-based things will be shared by another amazing speaker. So stay tuned to our next webinar too.
All right, guys. So we also have a form link. So we have a feedback form, so you can fill that if you have any suggestions or something. And don't feel sad if you missed out your question today. We'll also be having a question and answer session tomorrow. So do tune in with us. And thanks for joining us, guys. Bye bye.
Thanks for joining. Stay tuned.